A pleasant greetings to all. In this video, I am going to explain Z parameters or impedance parameters of a two-port network. First of all, we are going to see what is port in a network. There are three different ports available. The first one is one-port network. Second one is two-port network. And third one is N-port network. First of all, I am going to explain the one-port network. Any network may be diagrammatically represented by a rectangular box. If the rectangular box that consists of two terminals, that is known as one-port network. So, one port that consists of two terminals. Any active or passive network consists of only two terminals can be represented by one-port network. So, this is the representation of one-port network. Here the terminals A and B. And the general form of representation of one-port network is one-port network. Here we are having two terminals. And next I am going to explain about two-port network. Here the network was represented by a rectangular box. It consists of two pairs of terminals. Two pairs means four terminals. Here two terminals, and next we are having two terminals. In such a network, the resistance is connected in between the terminal. Okay, this is the two-port network. A and A, B, B dash. Okay. In a two-port network, current entering in one port, current is leaving in another port. And next I am going to explain the N-port network. So what is N-port network? Here in a N-port network, any network can be represented by a rectangular box. Okay. Here N terminal, we are having N terminals. So this is the N-port network. Okay, an N-port network contains of N pairs of terminals. So it is called N-port network. The driving source may be connected in more than one numbers of pairs of terminal. Okay, this is the one way of representation. This is the another way of representation. N-port network. Here this is the pair of terminals, lot of pairs of terminals. There is n numbers of pairs available. Okay, these are the different ports available in a network. Next I am going to explain two-port network. A pair of terminals through which current may enter or leave a network is known as port. Two terminal devices or elements such as resistors, capacitors and inductors are one-port networks. Most of the circuit elements are two-terminal or one-port circuit is represented in figure A. Here, the voltage across the current through a single pair of terminal is considered such two terminal of resistor, capacitor or inductor. Here we are having the resistor that is connected between two terminals. Four-terminal or two-port circuit involving op-amps, transistors and transformers as shown in figure B are also considered. In general, the network may have N-port. Okay, this is the two-port network. Here the current I1 is entering. Here also the current entering. the source given to the port 1 is V1 and the next two terminals are V2. A port is an access to the network and consists of a pair of terminals, the current entering in one terminal leaving through another terminal so that the net current entering the port is equal to 0. Here are some important points of the two-port network we are going to consider. Here this is the two-port network. A two-port network has two terminal pairs acting as access points. Next, three terminal devices such as transistors can be configured in two-port networks. Two-port networks are useful in communication, control system, power system, and electronics. Knowing the parameters of two-port network enable us to treat it as black box when embedded within a larger network. To characterize a two-port network, it is required that we relate the terminal quantities V1, V2, I1 and I2 in figure, out of which two are independent. The various terms that relate these voltage and currents are called parameters. Okay, next, how to write the equation. CV1 that is equal to Z11 into I1, the impedance parameter associated with this first port, and then the parameter that is shares between two port, first and second port, that is Z12 into I2. What is V2? V2 also Z21 into I1. Z22 into I2. In this way, first you have to write. Then what is Z11, Z12, Z21 and Z22 are network functions or called impedance. These parameters can be represented by a matrices. We may write the matrices equation as P is equal to Z into I. V is the column matrix here and Z is a square matrix 2 cross 2 and I is the column matrix. Here this is the way to write in a matrix form. The individual Z parameters for the given network can be defined by setting each of the port current equal to 0. Suppose the port 2 is left open circuited, so I2 equal to 0. Here this port is open circuited means what about I2? No current is flowing. What is Z11? From this Z11 equal to V1 by I1. Z11 is the driving point impedance at port 11 with the port 22 open circuited. It is called open circuit input impedance. And next I am going to explain Z21. Z21 is the transfer impedance at the port 11 with the port 22 open circuited. It is also called the open circuit forward transfer impedance. Suppose the port 11 is left open circuited, then I1 equal to 0. Okay, so Z21 is V2 by I1, I2 equal to 0, and Z12 is V1 by I2, I1 is 0. Z12 is the transfer impedance at the port 22 with the port 11 is open circuited. It is also called open circuit reverse transfer impedance. And the last I am going to explain is Z22, that is V2 by I2. Which one is 0? I1 is 0. Where Z22 is the open circuit driving point impedance at port 22 with the port 11 open circuited. It is also called the open circuit output impedance. The equivalent circuit of the two-port network governed by here Z11 is V1 by I1, Z22 V2 by I2. These are the transfer impedance Z21 Z12, V2 by I1 when I2 equal to 0, V1 by I2, Y1 equal to 0. So see, the same way already we have drawn now, in this way have to connect, put V1 and V2 first and Z11 that is corresponding to I1 that is for this port and here Z12 that shares the current I2, Z1 to I2, and Z21 I1, and Z22 into I2, that is it is connected, Z22 connected across the voltage V2. That's all. This is the impedance parameter in a two-port network. Thank you. Have a nice day.